You know, in most industries, mistakes happen. It's just a part of doing business. But in the nuclear industry, a single mistake? That's just not an option. So today we're going to crack open the rulebook that governs a world with absolutely zero margin for error to see how safety is literally written into every single move.
So, how on earth do you even do that? How do you build a system for something as powerful and, let's be honest, potentially dangerous as nuclear energy? I mean, it's a huge challenge, and it's one that's been tackled with one of the most comprehensive sets of rules ever put together.
The answer? Well, it all starts with a rulebook. But listen, forget any instruction manual you've ever seen. This thing is a foundational document called a Quality Management System, or QMS for short. And it is designed to govern every single action that could possibly, even remotely, affect safety. And to really get how important this is, you gotta look at who signs off on it. This isn't just some internal memo that gets passed around. The QMS is a serious commitment, signed by the entire company leadership. I'm talking from the president and CEO all the way down. And it's all done under the watchful eye of the ultimate authority in the US, the Nuclear Regulatory Commission.
Okay, so with that level of sign-off, what's the one guiding principle? What's the North Star? It's actually not just about rules and procedures. It's about building an entire culture around one single non-negotiable mandate.
The QMS itself defines this thing called nuclear safety culture. And the most important part is right here. Emphasize safety over competing goals. Just think about what that really means for a second. In a world that is completely driven by deadlines and budgets, this document legally binds the company to put safety first. Always. It beats schedules, it beats costs, it beats everything else, full stop. And look, this isn't just some feel-good mission statement they hang on the wall. It is baked into the company's identity, right down to their official quality logo you see right here. The whole organization is built around this pyramid, with quality and safety as that unshakable foundation at the bottom. So we get the philosophy behind it, but what does this rulebook actually look like on the inside? How's it put together? Let's break it down. Honestly, the best way to think about the QMS is to imagine it's an operating system, like on your computer. It's the foundational code that's always running in the background, making sure that every other program, every procedure, every single task runs safely and exactly as it's supposed to. And this operating system is organized in a really clear way. Level 1 is the QMS itself. That's the Constitution, the big picture. Level 2, those are the laws, the company-wide policies that put the Constitution into action. And then you have Level 3, which are basically the instruction manuals, the super detailed step-by-step procedures for every task you can imagine, from tightening a single bolt to designing an entire control system. Now, this diagram from the QMS, this shows you the engine of the whole system, and it's really all about a feedback loop. See, you start with requirements from customers and regulators. That input flows into the actual work, designing, building, all of it. But it doesn't just stop there. The output is constantly measured and analyzed, and all that data gets fed right back into the beginning. It creates this permanent cycle of learning and getting better. But hey, theory is one thing, right? A diagram looks nice. The real question is how a system this complex actually performs when it's under real pressure. So let's look at a real-world test. So when a true crisis hits, when the unexpected happens, does this massive, complicated rulebook bend the way it's supposed to, or does it just break? The answer? Well, it comes from this document right here, a final safety evaluation from the U.S. Nuclear Regulatory Commission, the NRC. These are the ultimate referees for nuclear safety in the United States. If they say it's safe, it's safe. The big test came in the form of what the documents call exigent conditions. It's a fancy phrase, right? All it really means is an urgent, totally unforeseen situation. In this specific case, it was the national emergency caused by the COVID-19 pandemic, which, as we all remember, severely restricted travel and access to just about everywhere. And here's where the rubber really met the road. The QMS has a super strict rule. All safety-critical suppliers must be physically audited every 3 years, period. No exceptions. But during a global lockdown, that suddenly became impossible. So the company had to go to the regulator with a formal proposal. Can we temporarily extend the audit deadline, but only for as long as this crisis lasts? This moment right here, this is where the system truly gets put to the test. A company can propose a change, sure, but the regulator's job is to pick apart every single detail. It's that classic idea, right? Trust, but always, always verify. So on the left, you can see the company's proposal, explaining in detail how they'd keep monitoring their suppliers. And on the right, that's the NRSC's analysis. And believe me, this is no rubber stamp. The NRSC staff did a deep technical dive into the request, thinking through every possible safety angle. And in the end, the NRC didn't just say, yes. They said, okay, yes, but, and then they laid out a really strict set of conditions. Suppliers still needed an approved quality program. That was non-negotiable. Performance monitoring and annual check-ins had to continue. And, this is critical, the extension was only temporary and it didn't give anyone a free pass. The audit clock didn't just reset. These are the kinds of safeguards that keep the system robust.
And here it is, the final verdict. After all that scrutiny, all that back and forth, the NRC found the proposed change to be an acceptable method. This is exactly what you want to see. It shows the system worked. It was rigid enough to guarantee safety, but it was also flexible enough to adapt to a genuine, once-in-a-generation crisis without compromising its core mission.
You know, this whole crisis, it reveals something really fundamental about how nuclear safety works in the real world. And it leads to probably the most important insight of all. A rulebook for something like nuclear safety just can't be carved in stone. It's impossible. Because technology changes, the world changes, we learn new things. So the rulebook has to change with it. It has to be a living, breathing document, designed from day one to constantly adapt. And here is the proof, right out of the latest version of the QMS. This is just a list of its most recent changes. You can see dozens of little tweaks and updates, adding in new standards, incorporating lessons learned from the field. Every single line item here represents the system getting a little bit smarter, a little bit stronger, and a little bit safer. So it leaves us with this final kind of fascinating thought. We think of nuclear power as an industry that demands absolute, unwavering stability and predictability. But what this deep dive into its rulebook really shows us is that maybe, just maybe, the ultimate safety feature isn't being rigid, but having a rigorous, documented, and never-ending process of change.